as I committed yesterday to derive equations of motion calculus method, today I am going to derive the equation of motion by using our calculus. This may be difficult for lower grade students, and for the students who are not aware of the differentiation and integration. So I am not suggesting this lecture for the one who don't know the integration and differentiation methods. They can ignore this concept, they can ignore this video, and the one who is perfect with differentiation and integration, they can follow this lecture. Let us see our first equation of motion. As you know that acceleration A is equal to the rate of change of velocity. A can be written as dv by dt. That implies I can write that dv is equal to A times dt. dv is equal to how much? A into dt. So if I apply let us apply the limits. Say at time t equal to 0, the body has some initial velocity u is equal to u. Say otherwise u0 is equal to u. After some time t2 is equal to say t, the final velocity is said to be v. If it is like that, if I apply integration, this is integral of dv is equal to integral of a times dt. By applying the limits, here the limits to be for velocity, here the limits of time, here the velocity is from u equal to u to v. At time t equal to 0 to some time t. At time t equal to 0, the initial velocity is u. At time t equal to t, after some time t, the final velocity is v. As you know, integral dv is equal to how much? V. As I said, if you are not aware of the integration, please skip this video and go to the next video. If you are aware of integration, then follow this. Otherwise, you don't know how this step came. Okay? This is from u to v is equal to, as these equations of motion are valid only when the acceleration is constant. Only when the acceleration is constant. So here the acceleration is said to be constant, and I can take it outside. So a into integral of dt means t. These are limits from 0 to t. So what is this? This is upper limit, this is lower limit. By substituting upper limit and lower limits and substituting minus, so v minus u is equal to a into t minus 0. That's why v equal to how much? U plus at. This is our first equation of. Assume that an object is moving with certain acceleration a, and at an instant of time t, its displacement is say ds, and it is moving with a certain velocity v. Then its instantaneous velocity is given by instantaneous is given by v is equal to ds by dt. Is it clear? V is equal to ds by dt. From this ds is equal to v into dt. Is it clear? From our first equations of motion, v is equal to how much? U plus at into dt. So this is our ds. By applying our integration, what do you get? Let us see. Integral of ds is equal to integral of u into dt plus integral of a into dt. Limits, integral of ds is equal to integral of u into dt plus integral of at into dt. What are the limits? Say for example at time t equal to 0, here these are integrating with respect to time. Time t equal to 0, the body is said to be at the initial position, say 0 position. After some time t, it reaches to s position after some time t. So integral of ds means what? S within limits 0 to s is equal to u is constant, can be taken outside. U into integral of dt means what? T. From limits 0 to t plus a is constant, can be taken outside. Integral of t dt means t square by 2 within limits 0 to t. So this is s is equal to ut plus half at square. See, many students are asking me to explain integration. That's why I am explaining the integration and differentiations in basic mathematics lecture. So please go through that basic mathematics lecture, and then you see this, then you can understand this. So if I explain the mathematics here, you will miss the physics. That's why I am not explaining the mathematics here. In the lecture basic mathematics, I have explained a few differentiation formulae, and I told you how to use them. I also explained the basic integrations, and I explained how to do small integrations. If you can practice them, you can easily solve this. Okay, so this is our second equation of motion, s equal to t plus half at square. This is how we have achieved by using our differentiation and calculus method. Here you understood that the acceleration is taken as a constant. That's why the equations of motion are valid only when the acceleration is taken as a constant. If the acceleration is not constant, you are not allowed to use these equations of motion directly. Whenever the acceleration is different, variable acceleration, then we have different methods. I will explain those different methods in the other lecture. Now let us see third equation. As you know that acceleration is equal to dv by dt, we can multiply it with ds and divide it with ds. And now I would like to rearrange these terms. So a is equal to dv by ds into ds by dt. Our ds by dt is nothing but the rate of change of position, or the rate of change of displacement is nothing but velocity. I can write this as a is equal to dv by ds into v. By rearranging these terms, this is a into ds cross multiplying is equal to v into dv. Now applying the integrations, by applying the integration like this, this is I am integrating with respect to velocity. Here this I am integrating with respect to position. Here the a is taken as constant, a can be taken outside, a into integral of this is v into dv, integral of v into dv. So this is what integral of ds means, s. So a into s is equal to integral of v dv means what? V square by 2. Now I am applying the limits at the position 0, at the starting position. The velocity may be u, and after some position, after reaching some position, its final velocity is v, then a into s within the limit 0 to s. This is from u to v. By applying this upper limit and lower limit, what I get? V square minus u square by 2. So this is what? as. as is equal to v square minus u square by 2. That implies v square minus u square is equal to 2as. This is our third equation. This is called as the time independent equation. As you don't have time here, we call it as time independent equation. Even if you don't have any knowledge about the time, by knowing the initial velocity, final velocity, you can find its acceleration, or by knowing the other terms, you can find the position where it is after some displacement. So these are our equations of motion. In the next lecture, I would like to discuss some problems based on equations of motion. Get ready for them.